So Jack, I hear a lot of people talking about 250 ohm resistors in our control circuits. What's so special about 250 ohms?
The 250 ohms, a lot of your PLC inputs, DCS inputs and all will have a 250 ohm resistor like at the input point into the card where they take the analog signal and convert it to digital. So they take the 4 to 20 milliamps, and by if you apply Ohm's law across the 250 ohms, they take the 4 to 20 milliamps and change it to 1 to 5 volts to be used within the control system. And we'd like to demonstrate that. I have a Milliamp Calibrator here, a loop calibrator. We have it in source, and we're going to drive 4 milliamps with it. And all we're doing is taking the leads, going across the 250 ohm resistor, one lead on each side. And then we took our meter here, and we're reading DC voltage. And then we just went across the resistor here. We're going to measure the voltage drop across that resistor. So we have 4 milliamps. So your 4 milliamps times your 250 ohms, which should give you 1 volt. You can see we're reading 0.995 volts. I'm going to go to 20 milliamps. So if you take your 20 milliamps, which is I, and multiply it by R, the resistance, you should get 5, and you can see we're reading 4.89 or right at 5 volts. And then mid-scale, which would be 12 milliamps, should be reading 3 volts, and we're reading 2.994 volts.
And you can use that adjustment knob in mid-scale to drive any milliamp value you wanted. So if you were doing a calibration, you'd probably go to 25% scale and so on and so forth.
Right. You can drive it up and down here, and it's a real good troubleshooting tool, especially now they have clamp-on amp meters. So you could actually clamp onto an input signal, see what milliamps you have, convert that to voltage to make sure that your controller's reading right, or you're going into your input block, you have the correct voltage reading. Just a good troubleshooting tip as far as applying the Ohm's law.